Hi, welcome to clickmyproject.com. This is complete demo of BECAN, a bandwidth efficient cooperative authentication scheme for filtering injected false data attack in wireless sensor networks. Injecting false data attack is a well-known serious threat to wireless sensor networks, for which an adversary reports bogus information to sink, causing error decision at upper level on energy waste in en route nodes. In this paper, we propose novel bandwidth efficient cooperative authentication scheme for filtering injected false data based on the random graph characteristics of sensor node deployment and the cooperative bit compressed authentication technique. The proposed BECAN scheme can save energy by early detecting and filtering the majority of injected false data with minor extra overheads at the en route nodes. In addition, sync largely reduces the burden of the sink. This is flow of our project. At starting, sync node initializes all sensor nodes and generates keys for all the nodes. Using these keys, all sensor node establishes the pairwise keys. These keys are used to generate the MAC code. If sensor node having message to send to the sink, it first have to find the shortest path to the sink. For that, register shortest path algorithm is used. If node have message, it first sends to the all neighbors, and neighbors generates the MAC code using message, timestamp and pairwise keys. After generating MAC code, all neighbors sends MAC to the source node. Source node sends message and a MAC to the routers. Routers generates the MAC code for the given message. If that MAC code is matched with the neighbors generated MAC code, then it's set as accept, otherwise it's set as reject. In final, sync makes the decision. This is complete demo of our project. Consider this is a sensor network. From this sensor network, sync going to receive and process the data. For that, have to verify data is false injected or not. For that, we are using the BECAN bandwidth efficient cooperative authentication scheme for wireless sensor networks. Using this mechanism, we can filter the false injected data. And initially, sync node generate the keys for all the sensor nodes and then send it to nodes. Finished. Consider if node A have the message and have to send into sync, we'll have to find the shortest path using the Digistra's algorithm, and neighbors are DEH. First, in node A have to send message to the neighbors. Before that, neighbors and routers have to establish the pairwise keys using the keys already sent by the sensor sync nodes. Keys are generated. After that, source node A have to send timestamp T and message M to the routers or neighbors. After establishing pairwise keys between routers and neighbors, source node have to send timestamp and message M to the all neighbors. Neighbors going to receive first timestamp and then source node sends message. This is message. For that message, all neighbor nodes generates the MAC code. Neighbor generates the MAC code for the routers A, B, C and sync, and E have to generate. Node H all neighbors generates MAC code. Routers have to verify that MAC. Router A have to verify the MAC code generated by the neighbor node D. Result is accepted. And router B is going to verify that message. Likewise, node E. For neighbor node E, router B is verifying. For neighbor node E, router C is generating and verifying. Finally sync. And for neighbor node H, finally sync going to verify the messages. All are verified. Message is not altered. It is not a fault message, so sync can accept the message sent by the source node E. This is our complete project.